Okay, we were talking about the conditional randomization assumption, and I skimmed over the fact that there's actually also another assumption. It's not just conditional randomization. You also need positivity. Is this subtle? So I'm just going to go over it pretty quickly. Um, Here, I said if you have this conditional randomization, you can do this short little proof and show that you can transform this thing that you care about, which is the average of this potential outcome, to this average of averages in subgroups based on observed data. Cool. And there was this step here where I'm asking about the expected value of this conditional expectation of y given x a equals a. So again, this is asking about a subpopulation defined in terms of covariates and a certain who are getting a certain treatment in that subpopulation. Now, the problem is that this thing does not exist if for some subpopulation there's nobody who gets the treatment. So, for example, if people in a particular zip code are never, ever, ever incarcerated, then there's no expected value of y in that subpopulation because that subpopulation just doesn't exist. So it's kind of subtle, but this definition requires there to be requires this joint probability to be non-zero, and or assuming that the marginal probability of x is positive, because otherwise why would you have that there? Equivalently, you can just say that the probability of a given x is non-zero for all x. So concretely, what this means is that in every subpopulation, you have some people who are treated and some people who are not treated. You can't have some subpopulation where nobody gets treated or a subpopulation where everybody gets treated, because then there's just no way to know about what the counterfactual is in that subpopulation. It's kind of like you haven't a randomized trial. So this is giving us that randomization, right, in that subpopulation. So you have a randomized trial, but your randomization is you flip a coin, and with probability 1, it's heads. So you did flip a coin, but everybody's getting the treatment, and so you can't say anything. Whereas even if you had some very tiny probability of getting tails, with infinite data, it doesn't matter. Like, that's still enough to tell you about what happens when these people are not getting the treatment. So this is trying to rule that out. So technically, this is a separate assumption called positivity, and it's important to think about, because let's say that you're estimating the effect of giving metformin versus insulin. These are two common drugs for diabetes. You want to see what's the effect on blood sugar based on observational data. You often encounter this case where, based on medical guidelines or laws, state laws, for another example is like, if you're looking at the effect of like food assistance programs, right? State laws often dictate that you need to make if you make a certain amount of money, or if you have a job or something like that, or don't have a job, then you get kicked off these assistance programs, or you're not allowed to have them. And so there's often cases where certain subpopulations cannot receive a treatment and others must receive a treatment. So here we have medical guidelines dictate that for anyone with blood sugar, this is made up, by the way, but imagine that this were the case. Anyone with blood sugar greater than 8, you must be on insulin. And so what's the problem here? The problem is that for anyone who's blood sugar greater than 8, they're all on insulin. So I don't have any data about, even if I collected infinite data, since all of that data is being drawn from this population that is obeying this law, I'm never going to see somebody who has blood sugar greater than 8 on metformin. So I can't tell you what the effect of giving them metformin would be. So that is an issue. I cannot estimate this effect in this population. Now, perhaps I could estimate it in the population of people with blood sugar less than 8, because in that case, maybe there's some chance that they're getting one thing versus the other. And so this is a problem, and there's often, like I said, for the effects of laws and things like that, you see this kind of issue with the positivity, what they're called positivity violations, and they're often in cases in kind of subsamples, right? So this is a positivity violation in the subpopulation where people have blood sugar greater than a particular value, and there's a lot of clever work often that goes into trying to get around this and estimate causal effects other ways that we you can learn about in other classes.